Hello class, welcome to the next lecture on programming in C, and in this lecture we'll be talking about, or we'll have an introduction to the concepts of algorithm and flowchart. Okay, so what is an algorithm? What is an algorithm? So basically I'll just write down the definition. Okay, algorithm is a complete, detailed, step-by-step method for solving a problem. Not only it should be solving, it should be what? Independent of the programming language used. Right. So the thing is that let's start from the bottom. It should be independent of the programming language used. That is, when you're writing an algorithm, you should be able to adapt this particular algorithm to whichever programming language we are using, because basically we are just writing down the logic. The implementation differs from language to language, right? And the other thing is that it should be complete. It should be a step-by-step method for solving whatever problem, and it should be detailed. Now, coming to a flow chart, it is just a pictorial representation of an algorithm. Right. So basically, these are both of these, algorithm and flowchart. Both are tools used by the developer or the programmer for solving a problem, and it is used to lay out a detailed logic for solving the problems. Once you have an algorithm or flowchart in your mind, or once you have penned it down, you can develop the program from there. It need not be like you have to first develop the algorithm and then you have to go to the flowchart, or you have to first develop the flowchart and then you have to write the algorithm. It depends on the type of problem. Some problems, and also the person, the individual. So some people may be comfortable with the flowchart, and some people may be comfortable with an algorithm. And some people, and many times it's once you are comfortable with coding and you are practiced enough, you may not even write an algorithm or a flowchart. You may even directly start writing the code if you are good enough, right, or if you are practiced enough. But still, then again, it is always good to have a algorithm or flowchart laid out, because it helps you visualize, or it helps you to see the logic properly. Okay, so the thing is that in algorithm, what you will be doing is that you will be just algorithms. You can approach it in two ways. One is that you can write step 1 this, step 2 this, step 3 this, like that. You can write step by step, or you can write you can use this thing what is called as a pseudocode. That is basically you will be using something a little bit similar to some programming language. For example, you will be in this different steps. You may be writing or let's say move 3 to variable A, move 5 to variable B, add A and B, right? Step 4, if add A and B and store in C, let's say, right? And if C is greater than D, then go to certain step. Like that you can write. In pseudocode, this is a little bit cumbersome. You can simply write A equal to 3, B equal to 5, C equal to A plus B. Then what if C is greater than D, then do this, else do this. So here you can see this may look like some particular language, it may not look like some particular language. This is sort of an informal, right? Pseudocode is an informal way of writing an algorithm, but it is more convenient. And in most of the problems that we are encountering, I'll be using a pseudocode method because this is cumbersome and it takes a lot of time. And whenever we have problems pertaining to numbers, pseudocode is a much convenient method. Okay. Now the next thing I have to mention is the symbols used in flowchart, because I have already mentioned that flowchart is a pictorial representation and it will be using certain symbols. The details, I'll just mention what the symbols are and what they are used for, and once we start seeing some examples you will get a hang of things. Okay, so this first thing is an oval sort of shape. It is used for start and stop. Okay. A rectangle is a process box. A parallelogram is a input or output box. A diamond is a decision box. Arrow, right, it shows the flow of control flow. Control flow means from one point to another, how from which point to which point the program is executing, right? Then we use this particular symbol for writing comments. This thing, comments, is a very important part of writing any program or algorithm, because that is sometimes as a programmer you may go on writing the program and you may know what the logic is, but one of the important characteristics of a program is that, good program is that it should be readable by others. So comments help a lot in that. It denotes to others, okay, what the programmer is using a particular step for. Okay, and this is a predefined process. It is sometimes called as a function. Okay, this thing is an on page connector. This is an off page connector. Okay, so let this sink in. We have start and stop, that is at the beginning and end of each flow chart we'll write start and stop to indicate ending and beginning of a flow chart. Then process box, for example here we wrote c equal to a plus b, right? So that is the process that is denoted using a process box. Then input, if you are reading or writing something from to the user. Then decision box, that is here we used if, right? That is if something is, then particular thing has to happen, else then something has to happen. That is a decision. So that we use here, that it will have two branches, yes and no. Okay, and control flow, that is from start it has to go somewhere, then you will put an arrow. From the process you have to go, those things. The movement control flow, it is shown using arrows. Then comments, predefined process function, like many times you may have to use certain things that is already defined. That is for example, if you have to do a process A multiple times in different position locations of the program, so what you do is that instead of writing the whole process for A every time, you predefine that area, that set of codes or set of logic as A, and you keep it somewhere, and whenever that is required you just denote, okay, A, process A is happening here. That is a predefined process, or in programming language we call it a function. It is a very important part of programming. Then we have the on page connector, that is if you are showing once you are writing drawing a flow chart and you have reached the bottom of the page and you are starting from the next side, okay, then you write, okay, it is A, and you start A. Okay, so you are using the same symbol, so you know from here it is continuing from here, like that. Off page connector, the same concept but different pages, right? So this is a different what basic understanding of what an algorithm and a flow chart is. So in an algorithm we just I just mentioned what two ways of writing the same algorithm, and in flow chart I just went through the symbols using a flow chart. Okay, now let's do one simple thing using algorithm and flow chart, so you will get an understanding. I'm not taking any numerical example, I'm just taking a real life example that anyone can relate to. Okay, so the question is, write an algorithm and flow chart to make T. Okay, to make T. So we can do this in different levels, different let's say levels of details. So let's start. Okay, here I'll be using this step by step procedure for algorithm because numericals are not there, right? And it will be a little descriptive. Okay, so I'm taking step 1, take pot. Step 2, add ingredients. Step 3, what? Boil ingredients. Step 4, what? Serve tea. Pretty simple, right? So if you're drawing the flowchart for this, we have start. Okay, from start what do we have? We have to add the ingredients or take pot. So I am taking pot as an input, then I am adding the ingredients, right? That is also I am taking as an input, add ingredients. Then what? Boil ingredients. That is a process. Right. This also you can take as a process, but I am taking it as an input. Boil ingredients, then serve tea, stop. Here also you can give start and stop, no problem. Okay. So this is a pretty straightforward, nothing in there. Now let's redefine the question. Make tea. Also ask the user if sugar is required. Okay. So let's draw the flowchart first. Start. Okay. Take pot. So before before taking ingredients, you should know whether what sugar is required or not, right? So what I'm doing is I'm adding ingredients other than sugar. Okay, I'm adding ingredients other than sugar. Then what? I'm boil ingredients. Right. Now you have to ask a question. Sugar. Right. There can be two answers, yes or no. Let me draw it here. No. Right. If it is a yes, then what? Add sugar. If it is a no, then don't do anything. Right. Either way, what is the next step? You have to serve the tea. And stop. Okay. So what is happening here? Here you will see how we are using the diamond box, decision box, and also the arrows in here, right? So arrows are always coming here, and here from the decision box you are asking sugar, whether the person wants sugar or not. And if the answer is yes, then add sugar, right? Otherwise don't do anything, just come. Anyway you have to serve the tea, right? So the question is whether sugar is required or not. If sugar is required, add it and come to serve the tea, then stop. So writing the algorithm, how will it be? Step 1 is take pot. Step 2, add ingredients other than sugar. Right. Step 3 is boil ingredients. Step 4 is sugar required, right? Then if the question answer is if yes, go to certain step, else go to certain step. So I'm writing step 5 as add sugar. So if yes, go to step 5, else if sugar is not required, then go to step 6. which is what? Serve T. So that is it. So here what we have done is we have added a decision box. We have added a conditional statement, right? Conditional statement. Conditional statement, right? That is, we needed to make a decision for the flowchart whether to go this way or that way, right? So that is what we did here. Okay, so this was just to show you this you may not be considered as a proper example, but this is to give you an understanding that any issue, real life issue, can be solved, or the solution can be expressed as an algorithm or a flowchart. Right? Not only in engineering but in other professions also, there are situations where people write down the solution as a step-by-step thing, right? So I'm stopping this lecture here, and in the next class onwards we will write down algorithms and flowchart for different more computing type of questions. Okay, and we'll explore more new things. Okay, thank you.